Let's have a look at what we want to achieve in this module regarding our blockchain. I want to work with more realistic transactions. And for that, let's go back to how transactions are actually related to our blockchain, which we create to handle our own cryptocurrency. Our blockchain, you learned that already, is unsurprisingly a chain of blocks, and each block is simply just a collection of data and some metadata, you could say. Now, metadata is important for things like validating the chain, so for example, information about the previous block. But the data in our case should be a list of transactions. So it's not one transaction per block. You typically, and that's the same for Bitcoin for example, include multiple transactions in one block. And only if they are included in a block, transactions are treated as processed. So that is kind of the point of time when the money really arrived at the person you were sending it to. Now, how does a transaction look like, therefore? Let's say this is our transaction, and we probably want to have information about the sender, the recipient, and the amount we're sending. This seems to be a useful set of information we want to pass on, because this allows us to have all the information we need. We know who sends our coins, we know to whom we send the coins, and we know how much we're going to send. Now, at the current point of time, by the way, we don't really have any balances. We don't have any real way of controlling how many coins are circulating, and therefore right now you can enter any amount you want. We'll also tackle this throughout the course, of course. But this is how a transaction in its core should look like. Now, the idea is that we don't just have one transaction, but many transactions. They are all managed in a list of outstanding transactions. So these are transactions which have not been processed yet. The funds have not yet arrived at the recipient. But ultimately, these outstanding transactions will be included in a new block. This is referred to as mining a new block, and people participating in the blockchain network, some of them are doing this mining task. They are doing this for a reward, which we'll also include in this course. So they are doing this in exchange for some of the coins. This is how we can also control the amount of coins in the network. But the important thing for us is they do it. They take these outstanding transactions, therefore they reset the outstanding transactions, they empty that list, and they include them in a new block. And once this was done, and the block was verified by enough people from the network, also something we'll of course do in this course, this transaction is treated as processed and the coins are available for the recipient. Now that was a lot of information. We'll start simple here. We'll start with managing that list of outstanding transactions. We'll add this functionality of adding a new block, or we actually have that functionality already. We'll tweak it therefore, and we'll make sure that we can add the transactions to that new block. Now the question is, which kind of data structures do we need for all these things? Right now we only know lists, strings, numbers, and booleans. Now we certainly need strings, for example. The sender and recipient probably has some string identifier. The amount is a number. Booleans are always helpful for doing some if checks. And of course we also use lists. Our whole blockchain is a list. But let's have a look at all these complex data structures in detail. The transaction as a whole, for example. Right now it's only a number or a nested list in our list of blocks. Now that certainly does not suffice. To manage sender, recipient, and amount, we need a data structure which stores key value pairs. The order doesn't really matter. We don't care if in that data structure the recipient comes prior to the sender. Important to us is that we have some kind of information piece which includes sender, recipient, and amount all in one variable, so to say, all in one data structure. So we need that. We also need a data structure for the outstanding transactions, and there we need a mutable, so that means editable, list of values. The order also doesn't matter to us here, but the important part is that we can add it, because of course we want to be able to add new transactions and so on. And we also want to have a data structure for the blockchain, and there we also need a mutable list of values, and here the order does matter to us. So these are our requirements for the transaction-related things. 3 data structures we need for the transaction, for the list of transactions, and for the list of blocks. But of course we also have the block itself. Now, the block includes the list of transactions, the list of processed transactions which are included in that block. It also has some metadata, like the hash of the previous block. This is important for validating the entire chain. We're already doing this in some way in our current blockchain application. And it might include other metadata, like, let's say, an index. Now, this is optional here, but in general, this is how a block will look like. So we also need a data structure that can depict these requirements. It's comparable to a transaction, I'd say. There we have sender, recipient, amount. Here it's hash, index, and a list of transactions. And finally, we could, as a bonus, also manage a list of participants in our blockchain network. We have a transaction with sender, recipient, and amount, and that basically means that a single transaction looks like this, this, or this. We have a sender, that could be a unique identifier. Here it's a name to make it easier to read. A recipient, the same as the sender basically, or the same type of data. And the amount, which should be a float, because just as with Bitcoins, we're not only able to send full coins, but also fractions of it. And maybe we want to manage a list of sender and recipients. And such a list would basically include all these keys here, all these names, these identifiers, but only once. So we don't want to have max twice in there. And please keep in mind, the name is just a placeholder here. In the end, we would have a unique ID. So even if we have two people named Max, we wouldn't use their name, so we wouldn't have any duplicates. So we want to have each identifier only once. For that, we need a data structure which stores unique values, and the order doesn't matter here. That is what we want to have for the blockchain. That was a lot of information to digest. We'll of course implement this step by step. But let's now have a look at the data structure options Python gives us, and let's see which data structure might be suitable for which purpose.